So question 122 had three parts, A, B, and C. And the instructions say use angle relationships in the diagrams below to solve for x if possible. If not possible, state how you know. If it is possible, justify your solution by stating the geometric relationships that you're using. So I'll state my relationship right off the bat. For A, I'm using the triangle angle sum theorem. If you look at it, we've got three different angles here, and these three angles have to have a sum of 180 degrees. So the algebra statement that I write is, and I can zoom out a little bit to show you this, I end up writing that one of the angles was 3x minus 2 plus another one of the angles was 2x plus 3, and then plus the final angle was x plus 8. And that has to equal 180 degrees when I add them. So when I collect like terms and subtract the 9 from both sides and then divide by 6, I get that x has to be 28.5. And we were asked to find x, we were not asked to find the size of any one of the angles, so we would be finished at that point. For B, we have this diagram, and I can see because these lines are shown to be parallel, I know certain angles are congruent. So for example, it has to be the case that this angle is congruent to this angle because they're corresponding angles, right? So those two that I've marked in green are corresponding, so they have to be congruent. And then also, because these two angles, this angle here and this one, are they're called vertical angles, they're right across from each other when two lines intersect, they have to be congruent. So our final thinking is, hey, since this angle is corresponding to this one, and because the lines are parallel, we know they're congruent, and since these are congruent because they're vertical angles, it has to be the case that this angle 4x plus 18 has to be the same. The number of degrees in those has to be the same. So 4x plus 18 has to be 6x minus 28. So there's our relationship, right? The lines are parallel with a transversal, and alternate exterior angles are congruent. You can jump to that too. So it ends up being that x has to be 23. And then finally part C, I've added a lot to this diagram already. So we were given a pair of parallel sides, right? This side and this side are shown to be parallel. And because of that, this angle that is x here is an alternate interior angle with this angle that's x here, so they have to be congruent to each other. And I guess these two angles right here, I can see what I did. I took 180, took away the x, and then cut them in half. So each of those have to be 180 minus x all over 2. And I think what I did is I focused on these three angles. These three angles are forming a straight line. You can see this is a straight line in here. So what I said was 180 minus x over 2, that's this angle, plus this angle that's x, right, plus this angle that's 56, have to add up to 180. So that was the relationship I came up with. To solve this equation, I used fraction busters, and you can see I multiplied both sides by 2 in order to eliminate this denominator. And as I move forward, as I multiplied everything by 2, you can see this no longer has the divided by 2, but this had to become 2 times x, this is 2 times the 56, and this is 2 times the 180. So everything doubled. And then I collected like terms and subtracted the 292 from both sides and got that x had to be 68 degrees.